it's really hard to communicate, to understand what other people mean, and so communication is really difficult, and it all depends on the audience. I guess most of you are developers, I suppose at least, so I could probably show you a piece of code and you would not understand what it will do. So the receiver of the communication in this case, or the person that you talk to, must be able to understand it and must be able to come with their own examples, for example. And I would say that anyone can read this and hopefully even understand it. So we observe some kind of change in the system. We set it up, we use it, and then we see what happened. So a concrete example could be something like this. Given that I have a running calculator, okay, so that tells me a few things. I need to have an implementation of some kind of calculator. It must be running, otherwise I can't use it. And then I add some numbers, and then we should display something somewhere. We don't really know where, but we should do that. This is an example that anyone can read and understand. And it's hopefully expressed in the way that business people can understand. Another example could be this. We're developing some kind of e-commerce system. So we want to add an item to a shopping bag for some reason. So if I select the red t-shirt and then add it to the shopping bag, then it should actually be in the shopping bag. It's very concrete. You can't discuss this. It's either there or it isn't. Well, you can obviously choose an orange t-shirt if you have one, but they don't make these anymore. So I'm afraid you can't get hold of one of those if you haven't already. It's very important that we express ourselves in the language of the business, so the business persons understand what we actually mean, and they can contribute with their own examples. And if it's hard to find the real business value, well, ask them again, and again, and again. Be like a, I don't know, parrot, annoying, until you find really good examples. And there's nothing so annoying as a really good example, because you can't discard it. It's valid. What is the business value then? Well, that's a little bit fluffy, but it's probably something from this list. We want to increase the money we're making. We want to protect stuff we're doing today, or make today. Reduce costs, for example. Or, I don't know, provide more value to your customers, whatever that may mean. But it's something that the business understands. They understand cost. We should keep the costs low, for example. So that's a business value. The question then is, how should we write our examples? Because it is examples that we are writing. And we can choose from two different ways, imperative and declarative. An imperative, I mean, that's programming language like C or something. We tell some stuff what to do, and they do it. Another version is obviously declarative. We define what should happen. We don't really know how it's implemented, and we don't really care. SQL is a great example of that. That's actually declarative. We don't know how the database manager will do the lookup. We only define the properties that should be afterwards. And it's really important that we prepare for changes, because they will occur. Has anyone ever worked in a system that didn't change? No. So requirements usually change. And therefore, you would like to define what should happen and not how it's implemented, because that will hopefully change not as often as the actual implementation. Okay? And PDD in this case can help us build the right thing. TDD can help us build it the right way. So they are complements. Okay? So the question now is, how do we actually do this? Well, there are a few things that we need to do. First, we need to make sure that we create good examples. And by doing that, we need to gather the right persons who actually knows what the business wants. Some persons who know how to implement it, someone who knows how to test it, and perhaps a business analyst. What Cucumber talks about is the three amigos. So we need some kind of product owner who knows what they actually want, and then a few guys questioning that. These might, or hopefully will come up with good examples that actually will solve the problem that the product owner wants to have solved. So gather these persons in the same room and have them create concrete examples. That's the general advice in this case. And there are obviously lots of different techniques on how you can do that. And well, story mapping is perhaps one of them. Impact mapping, I don't know, user stories, whatever you need. But at the end, make sure that you create concrete examples. I do that, or I have this one running. When I do that, then this should happen. I select the red t-shirt, I put it in the shopping bag, and then it should be in the shopping bag. You could obviously extend that one. I select the red t-shirt, put it in the shopping bag, and then I buy it, or I pay for it. And then it has been paid for. That's very concrete. So these guys, they should discuss, and then they should document the examples. And if they do that in something we call a feature. A feature is a file that contains a lot of different scenarios, and each example, or each scenario is one example, and you could have many examples, obviously, or many scenarios now. So, before I write some code, then let's see how's the tools like this, how are they built? Well, we always have some kind of feature. Okay, that's plain text, as you saw earlier. Then we need to execute this. So we need something that can execute, that can read these files and translate them into code. Well, they can't translate them into code, but they can translate them or interpret them so they can find the correct method that should be executed. So we need some glue that will connect us to the system under test. That is our production code. That one will obviously be exercised. We will get some change done that we can observe, and then we will assert that change somewhere. This is how all of these different tools are implemented, and there are numbers of them. I'm going to show you Cucumber today, but there are more tools. Fitness is not unknown, Robot Framework, Behaviour, there's a lot of them. And they all work pretty much this way. Okay, so time for some live coding. Do you hear what I say when I talk this? Yeah. Good. Okay, right, so some coding. I'm actually amazed that when I saw the specification for this conference, then it said that everyone should write code on stage. How many of you have seen code written on stage today? Yet? None?
Once.
Oh, one over there? Okay. I guess I'm the only one following the specification. Right, so what do we have here? Well, I have an empty example where I will implement some stuff. It's a Maven project. Basically, it will help me with getting some dependencies as well as running the test later on. What I need to do now is define a feature. We have some kind of feature. When I have 42 cubes in my belly, a lot of cubes, and wait for 1 hour, then there should be some graph for it. It's a feature file. It has to start with the name feature. And then the description. This one is a very short description. This could be an entire book if you wanted to. You probably don't want that. But this could be a story or something. And then we have one or many examples. In this case, just one example. They have to start with the word scenario. No, they should start with the word scenario or the word scenario outline. today I'm just going to show you a scenario. And then a short description about this scenario. And perhaps a few pukes isn't a good description, so let's call it eat many pukes. And then we have a keyword given. So this is where we set up the system on the test. This is where we get the calculator running, the web shop up and running for whatever we need. And in this case also I'll make sure that we eat 42 cubes. And then we want to execute a change in the system. This is done here. And finally we would like to observe change. So this is given something that is setting up. When I use the system, then something should happen. We must follow this format, and this is a language called Gherkin, if you are interested in that. Okay, so let's run this and see what happens. Okay, we have a build success. We can see that we have 5 tests that were run, 4 of them were skipped. The number 5 is, I'm not sure if it's a bug or a feature, but I would have expected 3, perhaps, because we had 3 steps. Anyhow, Cucumber is telling us that we have a problem. We have one scenario with 3 steps, 3 of them is undefined. But at the same time, we were given some code that we could use to get started. So I'm going to use this code to get started, and I'm going to create a class that actually will implement these steps so that we will be able to invoke the production system and verify that it works or not. That has to be done in the glue code that I was talking about. This one is perhaps be viewed as a runner and nothing else. So now we need some glue. And you can't implement the glue here. You have to implement it in a separate class. So let me create a separate class that I today call step definitions, like that. This one will define all steps that we need. These steps has to be in the same package or sub-package relative to the run cubes test. So I could have placed this in the sub-package if I would have wanted to. So let me just paste this here and see what I need to import. I need to import given. And I need to import pending exception. And we should use the Cucumber version of it. When, and finally then. Okay. So this is 3 different methods. Each of them would match one of the steps in the feature file. So this one will match this method. This one will match this method, and this one will match this one finally. You might see that these are regular expressions, and regular expressions are used to locate the method that should be invoked for each step that has been found in the feature file. I did get some suggestions about the method names, as well as someone has noticed that we have a number here. So I have a regular expression group that will pick up numbers. That number will be passed as an argument here, arg1. Arg1 is obviously a really bad name, so let's start with changing that. And maybe call it, I don't know, cubes. This one doesn't really do anything. We should write some code here. It currently just throws pending exception. Yeah, so let's run this and see what happens this time. So we don't get suggested steps. We will, however, know that we have got an impending exception thrown with a to-do, implement me. So we have some work that we want to do. We don't fail the system at the moment, or fail the test runs, but we want to implement this. So let's see how we can do that. Let's start by moving this one. We're talking about the belly here. So maybe we need a class that is called belly that will implement this. So I will start with creating that class, and that's a production class. So I'll put it in the production code here. And let's call that one belly. So belly equals new belly to start with, and then I'm going to have this one to eat many cubes. Okay. And it should eat the number of cubes that I send into it, like that. Okay, so this one obviously doesn't compile because this method doesn't exist. So let's create that method. Yeah. And I always make sure that I throw a not implemented exception when I create a method like this. It's very common that you throw that in this case you don't do anything. If you return something, you return null. But I think it's a lot better to have not implemented exception, because if I ever use this method, I can't ignore it. If it doesn't do anything, I can ignore it. In this case, I can't. So let's run this and see what happens. We all know what will happen. I hope at least. Oh, bummer. Not implemented exception. Well, that was expected, obviously. So let's bind this parameter to field. Like that. And let's see what now. Okay. We should now be able to run this testing from IDEA instead. That's faster. I don't have to change to load list. Okay, so we were able to implement some stuff, but we still have stuff that hasn't been implemented. I need to do that. So let's go to step definitions and do that. I wait 1 hour. Okay, so this is the time that we should wait. R1 is again really bad parameter name, so let's call that one waiting time, perhaps. And let's have the belly wait. Like that. Nope. Wait exists in Java, so I don't want that. Anyone have a good suggestion for method name? This is the hardest thing in computer science. Good variable and good method names. Wait, why? And I'm sure that we can come up with a better name if we really try. Let's create this one. We know what happens if we do that. So let's just add this one to field. Time, like that. Okay, so we have implemented 2 steps. We are interacting with the production code. The final step would be to verify that the belly actually grows afterwards. So I want to pick up this word as a parameter, and I want to assert that we actually get this string back from something. In order to do that, I'll have to add a group, a expression group, that should match something, and I'll just have it match any string, like that. Okay, the method name, let's remove grow, because that's not part of the method in a sense. And let's define that it should be a string and expected value sign, perhaps. I don't know. Start there. So, value get sound. This is like a doctor with listening to your stomach. Get that method, right? And let's not implement but instead, I made a mistake. I'm sorry. I want this one to return something, and it should return a string that is the actual sound, like that. And when I do that, my environment will help me with the return type and stuff, so that's a better way to do it. And let's return nothing, like that. Okay, this will compile. And if it compiles, we all know that it works, so let's ship it. Oh, no. Let's add an assert here. Assert that actual is expected using the ampersand matchers. I'll have to import that. That would be good. And I'll have to import this one. That would be good as well. Okay, so let's run this and see what happens. Oh, a failure. We expected a growl, but we didn't get anything. Okay, so let's implement something that will work. Get sound. Well, the simplest possible solution could be to just return growl here. But if I did that, then I would not be able to show you that we're actually using the parameters from the example. So I'm going to do a little bit more work. Let's do something like this. If number of cubes is greater than 41 and waiting time is greater than or equal to 1, then let's return growl. Otherwise, return nothing. Okay, simple enough. Although I would have preferred to have a unit test before I wrote this, but if you don't tell anyone, I won't tell anyone that we cheated. Okay, so let's run this and see what happens. It passed. Fantastic. So let's see if we can verify that we're actually using the parameters. Let's change this one from 42 to, I don't know, small random number, 70. That's the definition of a small random number. Oh, we expected to grow, but we didn't get anything. So we're actually using this number. Let's revert that change. And let's check if we wait for 0.5. Oh, that will probably do. Let's say if we don't wait at all, what will happen then? The same thing happens. So we are actually using these parameters. I could obviously change this one as well. I'm not going to do that. Nice thing that I haven't even thought of before, that I saw now, is that the Cucumber plugin in IDEA shows me which parts of my example will be picked up as examples. That's nice. Not really necessary, but nice. Right, so let's run this using Maven Okay, we have success. Nice. And since I'm able to run this using Maven from command line like this, it's very easy to integrate in the continuous integration. It's actually trivial. You may want to consider the phase, lifecycle phase, when you should do it. We're running this in the test phase at the moment. Could be better to run it in the integration test phase, which is possible, but you would have to do a little bit more work on it. And just for the sake of it, let me show you the project definition. How many in here are using Maven? A few. So most of you don't. Okay. So if you're not familiar with the format, then you might not understand too much of this. But this is all I needed to get this example up and running. I need dependencies to JUnit, and I need two dependencies to, I need two dependencies to Cucumber and one dependency to JUnit, and that's it. Right. So I claim that this is not too hard to get up and running, and yeah, I encourage you to actually implement this yourself. And I have prepared the exact same example on my blog, which should be available from the conference site, and I will also give you a pointer afterwards. So let's continue with the presentation now. So, some blood coding. As I said, this example is available on my blog. Check it out. So, why, how, and the last question is when. Well, unfortunately, not always. It would be nice if this were a new silver bullet, but it's not. Sorry. So if you were hoping for a silver bullet, look somewhere else. The question is, when should you do this? And I'm not sure if you have heard about the concept of Canevin. Has anyone done that? Done that? No? Okay. So Canevin is a Welsh word spelled like this in English. It's something that Dave Snowden has come up with, and it's a way of classifying problems. So we have 4 different types of classification. We have simple, and in the simple phase, simple area, this is stuff that we know how to do. Everyone knows how to do this. There's nothing interesting here. The connection between cause and effect is very, very simple, easy. We will understand it more or less immediately. There is a best practice that we can use here. This is really simple. Then there's another area, complicated. This is an area where we have a connection between cause and effect, but it's not direct. It is not very easy. There might be some expert in the world who knows how to do this, or a few. Not everyone knows how to do this. There are good practices here, not best practice. Next one is complex. This is the space where developers love to be. This is where we don't have a direct connection between cause and effect. We don't really know about the system. This is where we develop new products that hasn't been around before. This is where we implement the game changers. So this is the fun area. And then there's the chaotic area. Chaos. The house is on fire. You have to act. Then you have to check and then respond. This may end up in a bad way. It could be really bad for you. So you don't want to be here. So the question is, when should you apply behavior-driven development? Well, obviously not in the chaotic place, because you don't have time. Obviously not in the complex, because we don't know too much about it. But you should do it in the complicated, possibly in the simple, and the more you learn about the problem, it will move from complex to complicated. So that's the area where you should be able to use behavior-driven development. And if you haven't heard about this concept, Canevin, I suggest that you look it up. Google for Dave Snowden and Canevin, and you'll find a short introduction on YouTube, for example. It's well worth knowing. Okay, I saw a sign 3 minutes. That's perfect, because I'm done. And I'm still Thomas, I'm still from Stockholm, and I hope you enjoy this and you will be able to implement it yourself. Thank you for listening. And I think we might have time for 1 or 2 questions if there should be any. Otherwise, I'll be around.
You said that you should have written some unit tests, even though it was rather simple. Would you do that?
In this example?
Sorry?
Would I have written unit tests in this small example? Probably not.
So,
but anything more complicated than this, I would probably have created something that we could use as an acceptance criteria. This is how it should work afterwards. And then iron out the details using test unit development.
So it would be at a lower level?
The unit testing would be at a lower level, yes. So this is on a high level, and unit test is on the unit level. This could be also on the unit level, but yeah, depends a little bit. Yeah.
You write VDD tests while testing through the graphical user interface, XLM and stuff like that, so you have a end-to-end testing.
So the question is, would I use VDD to test the system through the user interface? Yes, sometimes. But I would make sure that I didn't test too much. I would make sure that I tested as much as I could, not using the user interface. And then I would probably have a few tests that tested the most important journey through my application using tools like Selenium, for example. Just to make sure that the system actually is wired up together properly, and when we start it, it actually works. But I would avoid doing a lot of work there, and prefer to test at a lower level if possible. Using Selenium, I mean, that's possible. It's a great tool in many ways, but it's not that fast. So the feedback loop is too slow. And you have to build the entire product, you have to deploy it somewhere, and then run the tests. So it's not that easy as one could wish. There was one more question, yeah?
You were running the main tests first, and it gave you an output with cucumber steps that you copied them to Flask. Is it possible to automate that, to upload it directly?
Yeah, so the question is, I ran the Maven, I ran Cucumber and got some suggestions for steps. Is it possible to automate this? I guess so, but I'm not sure why you would want that. Because you would like to have the control over it, and it's not that many methods that will be written. So I'm not sure that automating this is a good idea, but obviously it would be possible.
Well, just for the to allow me not to go and copy it every time.
And there are other ways to do this. I'm actually sure that the feature plugin in IDEA will help you as well. So you could create the steps just from the looking at the feature files. Okay, then I think we'll prepare for the next session. Thank you.